Hello everyone, welcome back to my YouTube channel. So in this session, let's discuss about research methodology and IPR Module 1 for 5th semester. So the research methodology, the question mark which will get in your mind that what do you mean by research? What a research about and what to discover, how to do this research, what I should do, why I choose this topic. So these all which will comes means we need to find a practical problem that motivates a research question, and again that will define your research project that leads you to get result or answers. So this will helps you to solve your practical problem. Okay. So why to conduct research? A good question. To seek the truth, to provide solution to a problem, to help decision making, and to discover new knowledge, you need to do a research. So what do you mean by research? It is an objective and systematic scientific inquiry or investigation into a specific problem that needs a solution. You can call that as research. So the meaning of research is it simply seeks the answer of certain questions which have not been answered so far, and answers depend upon our efforts, that is human efforts. So what it will do, the meaning of research is nothing but searching for knowledge, or it is a systematic and scientific search for relevant information on a specific topic, and also it is systematized effort to gain new knowledge, a moment from known to unknown, and also a careful investigation or inquiry, especially through a search for new facts in any branch of knowledge. So that research is an academic activity, and as such, the term should be used in a technical sense. And also, the term research means re plus search, means again and again searching to find out something. So, if a person again and again observes a phenomena, then he is collecting the data, analyzing the data to get the conclusion, so that a person again and again observes the phenomenon, then collecting the data, then observing, analyzing, then he will get to the conclusion. This is what we can call that as term research. So it has a three categories. One is observation. It is the most fundamental way of obtaining the information from the source and significant in itself. And also it's a model or simplified ways of describing very complex interaction in the form of statistical relationship. And the final category is the processes, that is algorithm, procedures, arrangements, or reference designs to get a certain desired result. So these are the three main categories. So what is the objective of research? Problem solving, innovation and discovery, throughout investigation and information utilization. So problem solving is nothing but it's a primary objective of engineering research is to address novel and significant problems. Researchers embark on projects with the intentions of finding solutions to challenges that are not well understood or have not been adequately addressed before. Innovation and discovery is nothing but you have to innovate and discover new things. Either it is theoretical and you need to have applied knowledge, and exploring engineering guidelines, standards, and best practice to avoid failures and ensure successful outcomes in both academic and professional things. That we can call it as thorough investigation and information utilization. And the main objective of research, first of all, the purpose of research is to discover answers to questions through the applications of scientific procedures. The main aim of research is to find out the truth which is hidden and which has not been discovered as yet. So, to explore and gain insights into a problem This is objective. You can call that as a exploratory or formulative research, and also to portray accurately the characteristics of a particular group of people or case study. You can call that as a descriptive. And the third one is diagnostic research studies, and the fourth one is hypothesis testing research studies. So these are the four objectives we'll be having. Studies, that is nothing but to identify the causes of problem, will be using the diagnostics, and to test a hypothesis of a causal relationship between variable, we go with hypothesis testing. And if you can compare here aspects, you can see if you're having a four different objectives. One is exploratory research and descriptive, diagnostic, hypothesis testing. The purpose of exploratory is to explore and gain insights into a problem. Descriptive is nothing but to describe the characteristics. Diagnostic is nothing but to identify causes or reasons for a problem. Hypothesis testing is nothing but to test assumptions about a population. When you're using exploratory research at the early stage of research, and descriptive will be used when the problem is clearly defined. Diagnostic will be used when causes behind an all known problem are to be found. At the same time, hypothesis testing will be done whenever a hypothesis or theory needs validation. So that you can ask in a exploratory research, what is a research problem, what is happening in descriptive, why it is happening in diagnostic, is assumptions true or false in hypothesis testing. This kind of research question you can ask yourself. For example, exploratory is nothing but exploring a new consumer behavior in digital markets, and you're doing survey on the student study habits, that we can consider as an example for descriptive. And investigation causes high employee turnover. Investigating the causes of high employee turnover, that may comes under diagnostic. Testing if new OS or iOS is more effective than old, that comes under hypothesis testing. And the next is motivation in research. Studies have shown that intrinsic motivations required, like interest, challenge, learning, meaning, purpose. These all are linked to strong creative performance, and also required extrinsic motivating factors like rewards for good work includes money, fame, awards, rise, and status, which are very strong motivators but may block creativity. For example, research outcome may enable obtaining a patent, which is good way to become rich and famous. Influencers, there are good influencers and bad influencers. So the motivation in research, which includes influences from others like competition, collaboration, commitment, and encouragement, also motivating factors in research. For examples, if my friends are all doing research, so should I? Or a person that I dislike is doing well, I want to do better. Like this motivate influences may happen. And personal motivation in solving unsolved problems, intellectual choice, service to community. And you can see the motivation in research, the desire to get research degree along with its consequential benefits, desire to get intellectual joy of doing some creative work, desire to be a service of society, desire to get respectability. These all are motivation. So you can see the types of research. One is a descriptive versus analytical. So descriptive research that will focus on describing a situation or phenomenon without manipulating variable. It aims to provide a snapshot of current state. For example, if you're doing survey on customer satisfaction at shopping mall, how satisfied customers are with their experience at the mall. So you'll be asking the customers whether the overall shopping experience or the availability of the products, the friendliness of the staff. This will all comes under descriptive research, whereas analytical research goes to a step further and analyzing existing data to uncover pattern, relationships, or reasons behind observed phenomena. For example, you'll be while doing the experiments, we should know why you are getting a solution, and the reason you should find. After getting some results, you should know the reasons why that result is coming. You have to compare that all. And the second type is applied versus fundamental. So you can see here applied is nothing but applied research seeks to solve practical problems or else addresses real world issues. So its goal is to provide solutions and is often more focused on immediate practical applications. Whereas fundamental research, on the other hand, is driven by curiosity to expand knowledge. It doesn't necessarily have an immediate practical application and often explores theoretical concepts. The third one is quantitative research, that is nothing but number game. Quantitative research involves the collection and analysis of numerical data, and it is focused on measurable variables to establish patterns or relationships. Qualitative research is nothing but qualitative research that will deals with the non-numerical data, often using methods like interviews or observations to explore underlying meanings, attitudes, or perspectives. You can see the example for qualitative and quantitative. In case of quantitative methods, you can see if a person is selling free ice cream and only one in 30 take the free ice cream, that will be interesting. But why you should take, that is what will comes under qualitative method. Conceptual versus empirical. Conceptual research that relate to some abstract ideas or theory, it is generally used by philosophers and thinkers to develop new concepts or to reinterpret existing ones. On the other hand, empirical research relies on experience or observation alone, often without due regards for system and theory. Research can be done in different ways depending on how we collect and analyze the data. And from the description of different research type, there are two main approaches. One is quantitative approach, the one is qualitative approach. The quantitative approach, the first method, means collecting the data in numbers. This data is then analyzed using strict and formal mathematical or statistical methods. For example, measuring student scores, temperature readings, production outputs, etc. And this approach is structured and rigid. That is nothing but meaning the process follows a fixed method. And quantitative research can be divided into inferential research, that is nothing but drawing conclusions about a whole population from sample, and experimental research, conducting experiments to study cause and effect, and simulation research, using models and simulations to predict outcomes. So inferential approach is nothing but its goal is to create database from which we can guess characteristics of population, usually done through surveys or observations. For example, imagine you want to know if most people in your city likes cricket. Instead of asking every single person, you randomly talk to 50%. If 40 out of 50 then they says like they cricket, you might conclude that most people in the city likes cricket. So this is inference. You're making a conclusion about the whole city based on just a small sample of people or a survey. Okay. And also asking 10 classmates if they like ice cream, then you are concluding that the almost all the classes will like the ice creams like that. And experimental approach is nothing but here the researcher has greater control over the research environment. Some variables are deliberately changed or manipulated to see how they affect other variables. For example, in a lab, scientist changes the amount of fertilizer given to a plant to see how it affects their growth. Giving two plants different amount of water to see which plants grow faster. This is what the example which comes under experimental approach. And simulation approach, here you can create an artificial environment to generate data and information. This is useful when testing in real conditions is difficult or risky. It allows us to study dynamic behavior of system in controlled systems. For example, using a flight simulator to train pilots without flying an actual plane, that comes under simulation. Or else playing a driving simulator game to learn traffic rules without driving a real car, which comes under simulation approach. The next is qualitative approach. This deals with a subjective assessment that is studying the attitudes, opinions, and behavior, and it depends on researchers' insights and impressions rather than numbers. And the data is non-quantitative and not analyzed using strict mathematical methods, and it will be having common techniques like focus group interviews, which comes under small group discussion, then projective techniques, that is an indirect method to get people's true feelings, and depth interviews, one-to-one detailed discussions, for example interviewing students about their feelings towards online classes and summarizing common opinions, which comes under qualitative approach, or else taking the feedback of faculties in the classroom. So asking friends how they feel about the new school canteen food and nothing their opinions, which all comes under qualitative approach. And the next is significance of the research. So you should know the significance of the research here, the progress which comes from the asking this progress which comes from asking questions. If we keep asking why or how, we discover new ideas, and which helps us to think logically and scientifically, means that research teaches us to find answers step by step and in an organized way, and this will be important for economy and business. The research helps to solve problems in business, trade, and overall economy, and this guides the government decisions. Many government policies are made using research findings as well as. And you should know one thing, that all the progress is born by inquiry, which means that all the progresses is born of inquiry. And you should have one thing in your mind, that doubt is often better than overconfidence, because doubt may lead to doubt may leads to inquiry, and inquiry leads to invention, and but the overconfidence will make you to go down. So this is a famous Hudson maxim in the context of which the significance of research can well be understood. Increased amount of research make progress possible. And this research, as everything whatever I explained earlier, so these are few points. The role of research in several fields of applied economics is and governments, and the same thing, business and industry. Research helps companies to solve problems and plan better. For example, a smartphone company studies customer complaints to design a new model with a better battery life. And one more significance is social science. Research helps understand how people interact and solve social problems. For example, a sociology studies why rural students drop out of school and suggest a way to improve attendance. And for the students as well as research can help build a career or earn respect. For example, a PhD student research renewable energy storage and later becomes consultant for EV companies. And for professional, it can be a job and income source. For example, a market research analyst studies trends and sells reports to companies. So these are all the significance of the research. And also one more, three more things are to two philosophers and thinkers. Research may mean the outlet for new ideas and insights. To literary men and women, research may mean the development of new styles and creative work. And to analysts and intellectuals, research may mean the generalization of new theories. So, research has its special significance, as we discussed till now. So the same thing I explained here, solving various operational and planning problems of business and industry, social scientist in studying social relationships and in seeking answers to various social problems. And in addition of that, to find to those students who are to write the master's or PhD thesis, research may mean careerism or a way to attain a high position in the social structure. And to professionals, It's a source of livelihood, and for the philosophers, outlet for new ideas and insights. And to literary men and women, it's a development of new styles and creative work. And to analysts and intellectuals, it may mean the generalization of new theories. And the research methods, which are like tools in your engineering toolbox, depending on the problem, you pick the right tool. So there are three groups. In the first group, you can call that as a data collection. For example, in engineering, if you want to know battery efficiency, you measure voltage, current, and temperature from sensors. And the second group is statistical techniques. Suppose you collect motor performance data under different loads. Now you use regression or correlation to find how torque depends on current. And the third group is to accuracy testing. After designing a buck converter, you simulate it and compare results with the theoretical calculations to check if your design is accurate. So these are the three groups. So you should know what is the research methodology. So on this, you can understand the difference between method and methodology. Here, the method is nothing but engineering tools. Methodology is nothing but the plan and logic. So that research methods is differ than research methodology. Research methods are nothing but techniques and tools to collect data, whereas a research methodology is nothing but overall strategy and logic. And in research method, you can get statistical test and evaluating the accuracy of result. Here, in case of methodology, why that specific method will be chosen, and you ensures results can be evaluated and repeated. So the same thing, the systematical solve the research problem. It may be understood as a science of studying how research is done scientifically. In it, we study the various steps that are generally adopted by researcher in studying his research problem along with the logic behind them. It is necessary for the researchers to know not only the research method or techniques but also a methodology. So you should know the researchers not only need to know how to develop certain indices or test, but you should know how to calculate the mean, the mode, the median, or the standard deviations or chi-squares, how to apply particular research techniques, but they also need to know which of these methods or techniques are relevant and which are not, and what would they mean and indicate, and why. Everything should know. The scope of research methodology is wider than research methods. Thus, when we talk about research methodology, we not only talk of the research methods but also consider the logic behind the methods, and we use in a context of our research study and explain why we are using a particular method or technique and why we are not using others, so that the research results are capable of being evaluated either by researcher himself or by others. So you should know the research method versus methodology. There are three types. One is library research, field research, laboratory research. So in case of library, you have two types: analysis of historical records and analysis of documents. In case of field research, you have non-participant direct observation, participant observation, mass observation, mail questionnaires, opinionaries, personal interview, focused interview, group interview, telephone survey, and case study and life study. And we'll be having a third type, that is a library research here, the small group study of random behavior, play, and role analysis. Can see in detail here the library research. So the methods which are historical records and document analysis. So if you are considering the example, studying the blackout of history, grid reliability improvement, and document analysis means from where you're studying from IEEE standards and data sheets. That is how to design a substation. And the second is field research. That is nothing but observation. Here there are three methods. One is non-participant observation. So for example, watch lineman at work, how he's doing the work and all without participating, you're just observing here. Participant observation, joining the solar installation team and you're doing work with them. Mass observation means hostile electricity usage to study. So here you can use the techniques like checklist, logs, photos, interviews, which all come. And the third one is a field research, which comes under surveys and interviews. We'll be using the methods, that is the mail questionnaire is nothing but industry feedback on power quality. This is example I'm telling. Opinionaire is nothing but EV users rating battery performance. Personal interview is nothing but you'll be asking the HVDC engineering how it was, the experience. Focused interview means the finding the solar plant MPPT issues. Group interview is nothing but students discussing transformer faults together. Telephonic survey is nothing but asking households about power cuts. Case study and life history is nothing but case study of smart city microgrid. Here you can use the techniques like long-term data collection, project analysis. And the last one is library research. Here method we can use controlled experiments with small groups. For example, load testing of inverter in lab. And should know the role play here. The students act as a grid operator versus consumer. Techniques which will be using simulation results, oscilloscope recordings, audio visual devices. And the next is research and scientific method. To really understand what research means, we must first understand what scientific method means. Research is not random searching. It follows a method that is nothing but scientific method. Research and scientific method are very closely connected, whereas the research uses the scientific method as its backbone. And research means asking questions like why does this happen? What are the causes? What are the effects? These questions are studied carefully either by doing experiment or by observing the things that they naturally occur. A researcher doesn't stop at just one result. He keep on trying again and again by repeating the things. And also a researcher looks at how result apply to bigger and more complex solutions. All fields of sciences may use different tools and techniques, but the philosophy behind research is same. That is, asking questions, forming hypotheses, testing, analyzing is the same. That common philosophy is what we can call that as research, that is a scientific method. Can see the scientific method flow chart. So here the research means we'll be doing the systematic inquiry to find causes, effect, and truth. But whereas the scientific method is nothing but step-by-step process to conduct the research. In case of research, what you are doing, asking the questions why it's happening, how it's happening, what is happening. But in case of scientific method, you will be doing the hypothesis and will be finding the possible answers. In case of research, you'll be doing the experiments and collecting the data, but in case of scientific method, you are analyzing the results and comparing with your hypothesis, and you're getting conclusion. If you are not satisfied with your conclusion, you will be again repeated the steps to get the different results. Then you're comparing that applies to border cases. For example, you can see if you're having a fertilizer and plant growth. So you were asking a question, which fertilizer works better? But you started to doing the hypothesis fertilizer. You are having some prediction that if fertilizer A will give faster growth, then you're doing the experiments, then you're collecting the data, analyzing the results, then you are concluding. So how we are doing now? By doing the experiment. How we are doing the experiment? You will be having the two sets. In set one, you'll be having the fertilizer A. Set B, you'll be having the fertilizer B. You'll be having the same soil, same water, same sunlight. Then you're analyzing the result, comparing the average growth of both sets. This is what we can call that as a research. In case of scientific method, what you're doing, you will be doing the hypothesis that you are predicting that fertilizer A will make plants grow faster. Then you are collecting the data, measuring the plant's height weekly. Then you are checking if plant A is taller, Hypothesis is supported, repeat to confirm. So this is what which can call it as scientific method. So key features of scientific methods. So which are same across all the sciences. The method is same in all branch of sciences. And you'll be always doing the pursuit of truth. The main aim of science is to find the truth logically. And we'll be using the three core tools, that is experimentation, observation, and logic. And we'll be finding the role of logic. That is, logic aids in formulating clear statements and testing possible explanations. The scientific method is the same in all branches of science. The same thing. Anyone who observes the facts, finds relations between them, and explains them systematically is applying the scientific method. For example, whether you study stars or bacteria, you follow the same logical process, that scientific method. So the goal of scientific method is the pursuit of truth. Science tries to connect facts in a systematic and logical way. For example, instead of just nothing that plant grows, science asks why they grow under certain conditions. And it has three main goals. One is experimentation, observation, logical arguments. Experimentation is nothing but testing and watching and reasoning from known principles. For example, to test if medicine works, scientists observe patients, experiment with the doses, and the reason based on medical principles. Logic is very important in scientific method. It helps in making clear statements, testing different possible explanations, and identifying the correct one. So the scientific methods basically postulates under the scientific method which relies on empirical evidence, and it utilizes relevant concepts. It is committed to only objective considerations, and it aims at nothing but making only adequate and correct statements about population objects, and it results into probabilistic predictions. And the methodology is same known to all concerned for critical scrutiny for all for use in testing the conclusions through replications, and it aims at formulating most general axioms or what can be termed as scientific theories. Research process, you can see the block diagram is very important. Defining a problem, then reviewing the literature, formulating the hypothesis, designing research, then collecting the data, analyzing the data, interpreting and report. FF indicates feed forward, that serves the vital function of providing criteria for evaluation, whereas F is nothing but feedback, helps in controlling the subsystem to which it is transmitted. So first one is defining research problem. First, clearly state what problem or questions you want to solve. For example, does online learning improve student performance compared to classroom learning? And steps two is review the literature, look at what others have already studied, review concepts and theories related to your topic, review previous research findings to avoid repeating the same work and to build on existing knowledge. And the third one is a formulate hypothesis, make a prediction or assumption you want to test. Example, students using online learning platforms scores higher than classrooms only students only. And we'll be having this design research, including sample design, plan how we'll collect data, decide on what on the sample size, that is how many people you will study, decide the methods that include survey, experiment, interview, and observations. The next is collecting the data, actually gather information from your sample, for example, conduct surveys, analyze the data, process the collected data using statistics, graphs, or comparisons, test if your hypothesis is correct or not. Interpret and report, draw conclusions, write a report or publish results so others can learn. So in detail, as per textbooks, you can take a screenshot, you can practice yourself. Formulating the research problem, extensive literature survey, development of working hypothesis, then preparing the research design, determining the sample design, then deliberate samplings. In that we'll be having deliberate sampling is nothing but a purposive or non-probabilistic sampling. This sampling method involves purposive or deliberate selection of particular units of the universe for constituting a sample which represents the universe. And simple random sampling, it is also known as chance sampling or probability sampling, where each and every item in a population has an equal chance of inclusions in the sample, and each one of the possible samples in case of finite universe has the same probability of being selected. And we'll be having this systematic sampling. In some instances, the most practical way of sampling is to select every 15th name on a list or every 10th house on one side of street and so on, sampling of the type known as systematic sampling. In stratified sampling, if the population from which a sample is to be drawn does not constitute a homogeneous group, then stratified sampling technique is applied so as to obtain representative sampling. And quota sampling, in stratified sampling, the cost of taking cost of taking random samples from individuals strategies is often so expensive that interviewers. And also cluster sampling and area sampling. Area sampling is nothing but it's a quite close to cluster sampling and is often talked about when the total geographical area of interest happens to be a big one. And here we first divide the total area into a number of smaller non-overlapping areas, generally called geographical clusters. Multi-stage sampling. This is also further development of the idea of cluster sampling. So in this technique meant for big inquiries extending to a considerably large geographical areas like an entire country under multi-stage sampling. The first stage may be to select large primary sampling units such as states, then districts, then towns, then finally certain families within towns. If technique of random sampling is applied at all stages, the sampling procedure is described as multi-stage random sampling. And we'll be having the sequential sampling. Later, we'll be collecting the data by observation, through personal interview, through telephone interview, by mailing or questionnaire throughout the schedules. Execution of the project, then analyzing the data, then hypothesis testing will be doing. So then generalization and interpretation, and at the end, preparation of the report or the thesis. So these are about research progress. So preparation of the result report, like how we'll do now. It starts with the introduction. You can see the preparation. The layout of report should be as well as the preliminary pages, the main text, and the end matters. In its preliminary pages, the report should carry title and date followed by acknowledgements and forwards. Then there should be a table of contents followed by a list of tables and a list of graphs and charts, if any, given in the report. The main text of report should have the following parts like introduction. It should contain a clear statement of the objectives of research and an explanation of methodology adopted in accomplishing the research. And next, it will be having the summary of findings. After introduction, there would appear a statement of findings and recommendation in non-technical languages. If the findings are extensive, they should be summarized. Then main report, that is nothing but a main body of the report, should be presented in logical sequence and broken down into readily identified sections. Later, I will be writing the conclusions. So at the end of the report, appendices should be enlisted in respect of all the technical data. Then you can write bibliography, that is a list of books, journals, reports, etc. consulted should also be given in the end. Index should also be given, especially in published research report. So criteria of good research. The purpose of research should be clearly defined and common concept be used. The research procedures are used should be described in sufficient detail to permit another researcher to repeat the same research for further advancements, keeping the continuity of what has been attained. And the good researcher is always the procedural design of the research should be carefully planned to yield results that are as objective as possible. The researcher should report with a complete frankness, flaws in procedural design, and estimate their effects upon the findings. The analysis of data should be sufficiently adequate to travel